Hello, my name is Rachel, and today we are going over a piecewise function by graphing it according to constraints given in an Algebra 2 honors question. The problem we are going to go over states, on one set of axes, sketch graphs of three different functions, each with x-intercepts at -3, 0, 1, and 4, a domain of all real numbers, and a range of y is greater than or equal to -6. Try to make the functions as different as you can while still satisfying all of the necessary conditions. Before we start graphing our three functions, let's go over what a function is. A function is a representation that shows a constant change in something. In a function, for every one x value, there is only one y value. This means that there can only be one graphed point for every point on the x-axis. We can tell if something is a function by using the vertical line test. If we run a vertical line in parallel to the y-axis, we can see how many points hit the line. If more than one point hits the line at once, then it is not a function. Before we start, we are also going to go over some of the needed vocabulary. The x-intercepts is where the line crosses the x-axis. Domain is the constraints from left to right, and range is the constraints from bottom to top. Now we can start to address our problem. We need to make three functions, or three lines that only have one y value for every x value, that hit the x-intercept at only -3, 0, 1, and 4, have a domain of all real numbers, and a range of y is greater than or equal to -6. I'm going to make the axes and mark the points where the lines have to hit the x-axis and how far down they all need to touch. A piecewise function is what we are going to be working with today. A piecewise function is a function made up of small linear functions, and it could be related to a real-world example like a heartbeat or a silhouette of a mountain range. When we make our piecewise function, we are going to make sure it touches all of the necessary points, has a domain of all real numbers, and a range of y is greater than or equal to -6. We can see that it touches all of the needed points, but how do we know if it has the right domain and range? We know it has a domain of all real numbers as long as the numbers that it is touching can be found on a number line. For example, this piecewise function touches -6 way down here, -3 on the x-axis, and it also touches 3 way up here. Because domain runs from left to right, we can measure it from that direction. This line has a domain of -infinity is less than x, which is less than +infinity. So we know that it will be touching all of the real numbers that run along the x-axis. We also know that it has a range of y is greater than or equal to -6 because the lowest number that the graph hits is -6. Now that we can see this graph follows the constraints, we have to make two more graphs that are slightly different yet still follow the same constraints. This next piecewise function shows that the lowest number it hits is -6, and it touches all of the necessary x-intercepts. And so does this last function. Now that we have been able to successfully make three functions that meet the necessary constraints, we are done. If you want to further challenge yourself, check out my other video that talks about square root functions. Thanks for watching my video, and see you next time!